The equivalent capacitance. Find the equivalent capacitance between points A and B and find the charge that is stored on capacitor C1. Now you can see that I have C1 and C2 connected in parallel and connected in series with capacitor C3, and you have the whole thing connected to a battery so that the voltage between point A and B is V. So first I note that C1 and C2 are in parallel connection. So the equivalent capacitance for C1 and C2, which I will call C12, is basically the sum of the two capacitances C1 plus C2. Remember, the condition is that they have the same potential difference between the two plates, and the charges stored on C1 and C2 will add up to give the total charge. Now this C12, the capacitance that replaces C1 and C2, is in series with C3. So I can say that C12 and C3 in series. Therefore, I can write the equivalent capacitance as equivalent capacitance is the product of the two capacitances C12 times C3 divided by the sum C12 plus C3. So if I substitute for C12 C1 plus C2, I will obtain my final answer for the equivalent capacitance between points A and B. This is going to be equal to C12, which is C1 plus C2 multiplied with C3 divided by the sum of the capacitances C1 plus C2 plus C3. Now, there is a second part of the question that is asking me what is the charge stored on C1. Okay, so to answer that question, I recall that the equivalent capacitance C equivalent is the total charge stored Q total divided by the potential difference between the 2 points V. So you can see that the total charge stored in the circuit will be then the equivalent capacitance multiplied with the voltage. So this will be equal to C1 plus C2 times C3 divided by the sum of the capacitances C1 plus C2 plus C3 multiplied with the voltage. Now I have these two capacitors connected in series, therefore they store the same amount of charge. So in series combination, the charge stored by C12, which is Q12, is equal to the charge stored by C3, Q3, which is the total charge, Q total. So this is basically, if we rewrite it here, C1 plus C2 times C3 divided by C1 plus C2 plus C3 times the voltage V. So we have, remember, these two capacitors connected in series and they're connected in parallel with this battery. So when this calls some electrons, this positive terminal calls some electrons from C12, we have an equal amount of electrons that are traveling to the other plate. So this and due to the conservation of charge, that leaves exactly the same amount of positive charge on this plate, etc. So these two capacitors will store the same amount of charge, which is the total charge that I have noted here. Now, the potential difference between the two, C12 plus C3, is V12 plus V3. That's equal to the potential of the battery, V. And C12 is the charge stored, Q12, divided by V12. So for V12, the potential difference between C1 and between the terminals of C12 will be equal to Q12 divided by C12. Okay? And that potential difference is also equal to the potential difference on C1, which is V1, that is equal to Q1 divided by C1. So remember that we have the same potential difference between these two plates in the parallel connection. So the potential between these 2 points is V1, which is equal to V2, which is equal to V12. Okay? So then I can write for C12 Q12 over V12 or Q12 over V1, which is Q12, since V12 is equal to V1, which is Q1 over C1, it is Q12 divided by Q1 over C1. So this tells me that Q1 is equal to C1 divided by C12 multiplied by Q12. So you can see that this is C12 is C1 Q12 divided by Q1. Therefore, Q1 is C1 Q12 divided by C12. Okay, so therefore the charge stored on the first capacitor Q1 is C1 divided by C12, which is the sum of the capacitances, C1 plus C2, multiplied by Q12, which is the total charge here that we have calculated. That is C3 times C1 plus C2 divided by the sum of the capacitances, C1 plus C2 plus C3, multiplied with the potential of the battery V. Okay, so in this example we talked about the equivalent capacitance between 2 points A and B first. First we see C1 and C2 connected in parallel. They have the same potential difference. Their charges add up. And the equivalent capacitance is the sum of the capacitances C1 plus C2. C12, which is C1 plus C2, is connected in series with C3. So their reciprocals add up to give us the reciprocal of the equivalent capacitance. Or for two capacitors in series, the equivalent capacitance is the product of the capacitances divided by the sum of the capacitances. So we see that the equivalent capacitance should be then C12, which is C1 plus C2, multiplied by C3 divided by C12 plus C3, which is C1 plus C2 plus C3. Now to find the charge stored on capacitor 1, first I note that the equivalent capacitance that I have just calculated is the total charge divided by the voltage between the two terminals, which is V. So that's going to be equal to Q total will be equal to V times C equivalent. And that total charge stored in series combination is the charge stored on C12, which is equal to the charge stored on C3. So these two are the same, which is equal to the total charge. And the charge and the voltage V12 between the terminals of C12 and C3 will add up to give me the total voltage V. Now C12 is the charge stored by 1 and 2, Q12 divided by V12. So I see that V12 is Q12 over C12, but V12 is also equal to V1, it's also equal to V2. So this is basically Q1 over C1. So I can see that C12 is Q12 over V12, which is equal to V1, which is equal to Q1 over C1. Therefore, Q1 is C1 over C12 Q12, and C12 is C1 plus C2. Q12 is just the total charge stored. It's the same amount of charge stored on C3, which is C3 times C1 plus C2 divided by C1 plus C2 plus C3, our equivalent capacitance between A and B, multiplied with the voltage V.